Pleasure to be here. Thank you to Ludmil. Thank you to IMSA. And what I would like to share with you is my experience with AI and ML and talk about the translational work. At the Post Institute of Data Science and Computing, in addition to being Director of AI and ML, I'm also Chief Innovation Officer and responsible for translational work between the concepts that are grounded in academia and require some AI, maybe not AI motivated solutions, and go into commercial implementation. I've had a very rewarding academic career. I've spent over 30 years in academia. I came here from University of Maryland, where I was a distinguished professor and director of an NSF Center. And I spent over 30 years there on faculty, and in my career I also ran a large institute at NASA Goddard, and I also worked on a Clinton's team where I was in charge of architectural procurement systems for electronic commerce. So while I've never left academia and had a distinguished academic career, I've always never lost touch with industry and government, and was always motivated in my work with practical problems. So what I'll describe today is what is happening here at the Post Institute of Data Science and Computing, and what I'm doing with my group in this arena. And since my task as a scientist and as a faculty here at the University of Miami goes beyond a regular faculty appointment as an endowed chair, we are working on a number of things, and primarily I'm empowering innovation across the entire university. It's not just mathematics, it's not just computer science, and it's not just physics. So we are doing work across the entire university and trying to find an interesting problem where we can power a practical solution. So today I'll just share with you how we nurture innovation at Post Institute. We'll talk about our team. We can talk about epicenter discovery. We'll talk about bridging academic success with commercial viability. And I'm happy to report that after 2 years since my arrival, we have 5 patents that are filed by university, and 2 of them are going to commercialization. And already today we have a first customer. We have Chanel, who is licensing our product for the product formulation, and many others on the way. And at the center of all this innovation is actually the center that I created back in the University of Maryland, which was a follow-on on the previous center, which called IUCRC Center. It's NSF-funded center called the Center for Accelerated Real-Time Analytics, and has a catchy name, Carta. Some of you may know about Magna Carta, so it's in the same spirit. And this center forms the academic foundation for everything that we are doing and fueling all these new things that I'll be describing today. So what we are trying to do, we are trying to contextualize AI evolution. So we have overview. I'll give you a very fast overview of landscape. We'll talk about key trends that are shaping the field. We'll talk about challenges and concerns. And then we'll talk about our journey. So what are we doing here at the University of Miami, and how we are taking advantage of all this revolution that is happening in AI, and what are we adding from the innovation perspective to make it reality. So we'll be talking about building trusted frameworks, and we talk about from promise to the lab market. We'll talk about our test bed that just got accepted by FDA and actually became a premises for a lot of patterns that I described that are getting commercial viability in these different companies on today's market. And we'll talk about the significance of this platform that we are still developing, it's still work in progress, but that the whole concept was conceptualized here at the University of Miami and the Institute, and now moving to the next level of the innovation. Then we'll talk about, in our presentation specifically, I'll zoom in on unveiling key challenges that propel our journey. So in the sense, what motivates us, what are the challenges, and how we are attacking and solving the challenges. We'll talk about security. How do we establish trust in AI? Many of you have heard about AI, you talk about presidential mandate, you talk about the trust that needs to be developed in AI, go from there. And then we'll talk about crafting the strategic roadmap from promise to the lab to the market. So in a sense, we are not just interested on the problem of national significance that have commercial values, we also want to see how do we take the solution to this problem from the academia and translate it to at least a minimum viable product, but more importantly, perhaps to translate it to something that gets adoption. And when I talk about adoption, I'm not necessarily talking about monetization. Because when people talk about commercialization, they usually talk, how much money I can make and all that. That's all beautiful, and we are all for it, and we are doing it. However, we are talking about even open source solutions. Just to give you an example, when I was heading CESDIS at NASA, Center of Excellence in Space and Information Sciences, Linux was developed there and was commercialized by the Red Hat, and it was 95, and I was a very young 32-year-old full professor and director of this institute, and I didn't know what hit me by the head. But the young guy came to me to tell me, I'm director of Red Hat and I want to commercialize this technology. And I said, great, what kind of press release I can get out of my center? I didn't realize the potential, and then of course I didn't take a single share because I couldn't and all that. But if you look at the first disk of Linux release, it was developed actually at the institute that I had many, many years ago. And the reason I bring it up, not just to brag about it, but just to tell you that problem of national significance and commercialization doesn't necessarily mean immediate monetization. Sometimes open source solutions that get viral penetration of the market eventually bring monetization in terms of consulting and other things, but are not necessarily give you an immediate licensing fee and other things. So it's okay to produce open source. It's okay to produce novelty and do disruptions in technology that are not immediately monetizable by different organizations. And then finally, I'll introduce you to the test bed, and I'll show what we are doing there and how we're expanding it in different fields, from cosmetic industry to the medical industry, to the weather, and many other opportunities here. So we have a very much multidisciplinary expertise. I do consider myself a computer scientist, although I know some mathematics. I have first degree in mathematics, but I'm very proud of this. But I don't consider myself a mathematician, especially around this crowd that is so world class and so renowned. But I'm delighted to be here and delighted to offer an opportunity to work together so we can find how do we bridge the gap and how we can use these mathematically inspired problems and find interesting solutions. In addition to having endowed chair in my tenure department in computer science, I'm also professor of radiology in the Miller School of Medicine. So we are doing a lot of work in diagnostic radiology, nuclear medicine, nuclear cardiology, clinical dosimetry, and clinical informatics. And I'll give you an example of exactly the project. So we have, I would estimate about 16 different projects that are happening across the University of Miami now that my group is heading. And many of them are funded from outside funding, some of them funded internally, and some of them still work in progress where we are trying to gain the right speed and take it further. Now, what we are doing here and what is unique about this opportunity is that we are bridging the gap. We are bridging the gap that exists between clinicians in medical school, engineers, weather prediction people, and computer science and engineering, right? So we are working together. We are creating this seamless environment where we can create solutions that would power different fields. And one of the things that I've decided from the get-go when I accepted this position is to concentrate on the horizontal technologies. We are not interested in one-off solution because I'm building a program, right? And I think we're very successful and we're almost there in terms of at least the minimum kind of viable program at the Frost Institute in terms of AI and machine learning, which solves a number of different problems. So we're looking at problems across and finding common denominator. And once we create solutions that are common to many different verticals, then we can easily, or at least easier, come up with customization that would enable us to adopt this technology to power novelty, to power different type of solution. And we've been doing it relatively successful, I must confess, and I'll give you an example of our success story so far, and the list is growing. And we go from there. For example, in the area of oncology, we are working on prognostic digital twins. We are looking at using AI technology to understand how to combat cancer, but in a different way, because one of the reasons cancer is not a chronic disease by now, because we don't understand how the cancer will metastasize in different bodies. So we want to understand the personalization, and we want to understand how to model at the molecular level different kind of oncological problems and see how specific kind of oncological problem will metastasize in different organs. I told you I'm on the faculty of radiology. We are looking at different kind of solutions where AI would actually read automatically the radiology reports, right? And not just it will read the reports, but it will also give you an understanding of what is happening in the clinical body and things like that. We are working with Boston Palmer, which is #1 eye institute in the country, probably in the world. And what we are doing, we are looking at computer vision technology through the retina of the eye to diagnose brain tumors, to diagnose different kind of diabetic diseases. And we have a huge progress, and again, this is something that we intend to patent the new technology, that by observing the retina of the eye, you can actually see the entire holistic view of the individual or patient, whatever you want to describe it, and understand the different state of the organ. Now, all of this is done under the premises of the Frost Institute, and at the Frost Institute we have a number of different verticals. We are looking at different applications. We are looking at earth system science, we are looking at digital health and life sciences, smart city and smart environments. And what is interesting that what I'm heading at the Institute, it cuts across all the different domains. So again, from the get-go, I took the approach that we are looking at horizontal solutions that power different type of applications. And given my background at NASA, of course, with weather predictions and working with the top astrophysicists and scientists in the world for a number of years, of course, we can power the Earth systems. Digital health is something that I've been doing for the last 20 years with the University of Maryland, and nowadays we are working on the interesting concept that you may or may not appreciate, but since eventually we are all going to age, we are working on the concept of smart homes with health nexus. And this is something that is relatively unique, but is very, very powerful and very, very practical. And the reason why it's practical, because nowadays the concept of proximity care is gaining tremendous attention. So people are no longer going as much to hospitals, they're going to clinics. And now the whole medical care from clinic moves to the comfort of the home. So we are working with the School of Architecture and trying to understand how do we bring all this novel technology from computer science, from computer vision, from sensoring technology, and try to enable us to get preventive care, diagnostic care, or maintenance care at the comfort of our home without disrupting the architecture and ambience of our home. So we don't want to go to a nursing home. We don't want to go to assisted living. We want to stay in age and die in our own home. However, we need help, right? As we grow older, the situation is not going to get better. We know it's at best it will stay the same. So we would like to have all this technology and methodology there. About a year and a half ago, or maybe a year ago, Lori Silvers, who is chairman of the board of trustees of our university, asked me to kind of describe where I see the next innovation goals and where a university can raise money. And this is the slide I came up with. So since young age, I think, and I, for the full disclosure, I was born in former Soviet Union in Ukraine, and at the age, I don't know, 16 or 17, I got into my head that I wanted to work on computer-based diagnosis, right? So, which is now probably called digital health or whatever it is. So this was my passion over the last 40 years. And about 20 years ago, I realized my dream when the head of surgery from University of Maryland walked into my office and asked me to help him and took me to the medical school and how the whole thing started. So when I arrived to University of Miami and joined Frost Institute, I started to think how I can combine my passion, because without passion you can't really work and do things that I'm doing, and see where the technology and the world is moving. So I decided as a part of our AI and ML program, we'll concentrate on two verticals. And this is just a start. I'm not saying this is going to be the only thing we'll be doing, but this is where the world is moving, and this is where we can really scratch the surface or make a dent, depends how fast and how deep we'll go. And the two verticals I've identified is digital health, where we would be working on the software as a device, healthy aging, digital therapeutics, music for dementia, which is another very interesting thing. We actually have very interesting results in this area as well. And then what I mentioned already, smart homes with health nexus. And on the other side, given my experience working with DHS and NSA, and remember I came from Maryland area, so working with all these three letters agency was almost a must for any successful professor there. So I've done a lot of work in zero trust supply chains, trust execution environments, blockchain powered, whatever you're doing. And I also added competitive digital games because when you look today at the sports and what is happening there, uh, I think more and more you see digitalization. People are not buying tickets anymore, but they are actually looking at digital twins and looking at this type of environment. Now, as I mentioned to you already, at the heart of all this research and science, there is a 15-year award that I've been fortunate to secure, a very competitive one. It's IUCRC, University Industry Cooperative Research Center, funded by NSF. It consists of 5 universities. I started the center when I was still in Maryland 6 years ago. Now we just got renewal for the next 5 years. It's like a 15-year, 5-year chunks. It's Center for Accelerated Real-Time Analytics. So there's a big history how the whole thing started. The whole thing started when IBM came to me in 2007 and said, Yelena, there is a big revolution in multi-core. You're going to be the only IBM multi-core computational center at the University of Maryland, but we just give you 2 years to win yourself out of this. We give you all the equipment, all the technology, we give you $2 million, but in 2 years, that's it, we're out. You have to evangelize the technology, you have to benchmark it, and that's it. So I panicked, and when I panicked, this is the best story, because, so I found this program, and we built an NSF center called Multi-Core Computational Center, called CHAMPA, Center for Hybrid Multi-Core Productivity. And when I was in the year A, which I had still 7 years here, left on the award, and the NSF manager came and said, Yelena, you have to build a big center in big data, because big data is a big thing. And I said, you know what? I ran a big center at NASA. I understand petabytes, I understand big data. The only reason the big data is big in 2013, 2014 is because of social media. And there is no reason for NSF to invest in a big national center in the big data. They said, you don't want another center for 15 years? I said, no. I said, what do you want? I said, I want Kafka, because you want actionable data. Big data is trouble. You have to curate it, you have to store it, you have to index it. But what you need an actionable data. And that's where the Kafka was born. So today it has 5 universities, 28 paying members, and Miami is, of course, since I moved here, as a part of this. So now we come to the main part of the talk. I give you kind of the landscape, what's happening at the University of Miami, at the Frost Institute, and what we are doing in general in the field of AI. And let's look at, step back and look at historical perspective. How did AI begin and where the roots are? I'm happy to report that AI has intriguing origins in mathematics, right? And I'm delighted to share this with you, because when you look at AI and you try to ask the question, what is AI? It goes all the way back to Thomas Bayes, which has significant contribution to the field of mathematics and probability theory, and this finds its way into artificial intelligence and machine learning and other things. So again, if you step back and try to analyze the contribution of all these famous mathematicians, starting with Bayes, they had tremendous impact on how the traditional and the modern AI is actually phasing. Then, of course, we go to Gauss, right? So Gauss' contribution to mathematics and statistics, again, laid the essential groundwork to development of mathematical and computational principles of the AI, number theory, Gaussian distribution, methods of least squares, linear algebra. All of this, again, if we trace it back to AI, is the foundation of what is happening. And finally, the main person is Turing, right? I propose to consider the question, can machines think? And this is where it all started, right? But if you trace back again, Turing was a mathematician. So the promise of AI. So this is just to give you kind of bridge the gap and maybe give you the comfort why Ludmila actually invited me to the Department of Mathematics to talk about it, because I very strongly feel that the field of mathematics was a foundation and perhaps precursor to what we now call traditional AI, and has many more contributions. And by the way, the field of AI is still in the development, and what AI it still doesn't work, because AI is about learning, right? So machine learning may work, but AI still doesn't work, and it's not supposed to work, because you continuously learn. And I'm of the opinion that AI is all the time is evolving. Okay. So we have this unprecedented capacity to learn and adapt. We have decentralized learning, gathering knowledge from diverse data sources. Then we have machine learning, learning patterns, making prediction, improving over time. And then we have transformative ability, enforcing decision making, improving efficiency, personalization of the patient care, huge thing that we're working a lot in this area. And then we have real world examples of AI in action, diagnosis, AI detecting disease early, such as diabetic retinopathy or cancers, prognosis, predicting patient outcomes, treatment planning, and all other activities that are happening. So AI in healthcare has tremendous potential, and the potential is being realized as we speak in different fields. As I mentioned, I'm on the faculty of radiology, and we have tremendous advancements there. We also have some new innovations that I'll be describing a little bit later here. So I'm working with a group of very capable physicians there, and we are working not just with radiology, we're now creating a larger group with radiation oncologists, and also working on radiomics and looking at pathology, because what is happening now in radiology has tremendous implications and novelty in also in pathology, where we have a concept of digital pathology, which enable us to cut down on number of unnecessary biopsies that are happening consistently for different number of reasons. NLP, or natural language processing, is another area that relatively well developed, but now getting kind of a second summer, if you will, or second spring, especially in the medical field. And one of the things we are doing, and that's another patent we are filing now, is how to use NLP to actually analyze the report and to do billing, which has nothing to do with clinical care. But believe it or not, and I'm sure you believe it, that especially in UHealth and many other organizations, billing is extremely important. So you can actually do multi-level modeling and using NLP to do automatic billing, and it turns out that it saves about 20%. So in a sense, radiology is underbilled. So they're doing the radiology reports, but they are not actually billing them properly, which results in a huge loss for the medical organizations, which is, again, it's a business solution, but it has medical implications, because of course, if you can bill better, you can improve the quality and bring other things that are more interesting. Well, I don't know how many of you keep up with the modern literature, but there is a presidential mandate. How do you worry about AI? How do you monitor AI? How do you deal with so-called trustworthy AI and things of that sort? So one of the main things that are happening now, and this is a big thing where actually I must report, it took us a while, but now we have a solid result in understanding bias in AI and its impact. So biasness in AI is a huge deal, no matter what the application area, whether it's a medical diagnostics or anything you do with AI, including business analytics or anything else. And basically, those of you who who are not very familiar with the concept of AI, defining bias is basically skewness in data or algorithms. And then, of course, there are political consequences, such as inaccurate predictions with diagnosis, health disparities. And I'm happy to report that we are part of $100 million NIH award for health disparity that I got here when I arrived at the University of Miami. And this project actually was mentioned by President Biden a week ago as a part of his, I think it was, I don't know how they call it, specific addressing issues. So he's going to continue this project for the next 10 years.
Smart city, called it smart city.
No, not smart city. It's called AI for health disparity. Not smart city. We are working in smart city school, but this specific project has to do with health disparity, and we go from there. And then, of course, exploring data drift and model drift. And this is the project that is actually funded, which has got a new grant from NSF and FDA to examine data drift and model drift and address this issue. We're looking at scientific approaches to address this challenge in mitigating bias, handling data and model drift, responsible AI, and of course security considerations. So this is basically the description of all the things. I'm not going to read all of this, and this is for you as a backup kind of slide. If you're interested in this work, we'll be happy to discuss. There is a lot of potentially applied mathematics, not geometry, but those of you who are statistically savvy and have an interest in this type of thing, there is tremendous potential here on working on this type of problems. In terms of trustworthy AI, we have statistical properties of the input used to train and deploy an AI model that change over time. We have challenges such as data distribution shift, covariance shift, label drift, and then there are a number of solutions that we've developed. Then we have algorithmic drifts. And the next thing you may ask, it sounds like a huge problem and you're trying to boil the ocean, Yelena, so what exactly you're trying to achieve with the group? Because the group is big, but, and of course we have other collaborators across the country, across the world, and in other places, but still the problem is too big. So our goal is here, while addressing a global problem, is rather confined and crystallized, and we are looking at transition from theoretical trustworthy AI challenges to practical real-world applicability, okay? So what we are doing here, we are building an infrastructure platform that aims to evaluate and facilitate the continuous monitoring and retraining of AI models operating in real-world application. And real-world application is a must, right? So while we are in academia, and we work on a very academically grounded and theoretical problems, we want to find practical solutions, and we want to motivate our academic solutions by the practical problems, so we can do this translation. So while solving our academically grounded problem, we can actually address and facilitate the solution of the practical situation. And I would say 65 to 70% of what we do is focusing on the medical applications. And remember, when we are talking about medical applications here, many of them are clinical, meaning they have to do with prevention, with diagnosis, with better treatment regimens. But some of them are actually medically inspired, which is social work, healing, and many other things that medical information that are wrapping around the clinical applications. So it's not all about the clinical care where we are empowering physicians at the point of care. There's a lot of this, but there is also a situation, let's say grandpa has a heart attack or needs a stent. Do we do the surgery on Wednesday or Friday? And if the grandpa can be picked up by his family and live nearby, you do it Friday. If he doesn't have anybody to pick him up, you do it Wednesday, because what will happen? The grandpa is going to spend another weekend in the hospital, which will cost money to the insurance, But also grandpa most likely will get some infection during this weekend in the hospital because nobody picks him up. And then grandpa suffers, insurance money will suffer, and all of these things will go from there. So it's ability to coordinate all of this. I was in the faculty in surgery in University of Maryland. You know, it cost about $3,000 at that time, now probably it's more, to operate operating room for 1 hour. So if you don't schedule the room, if you don't schedule the patient, you don't schedule the right nursing crew, if you don't schedule the right equipment to do the surgery, you're losing tons of money, okay? So they were worried, believe it or not, which sounds kind of crazy, but it's true, about scheduling OR rooms much more than getting better quality surgeons to serve the patient. They say, just get any surgeon on the floor that can do sinus. He's not going to kill the patient, but we need to make sure that the operation room is in use and things are not going through, not fall through the cracks and things of that sort. So when I'm describing all these AI tools, of course, we are taking patient-centric approach, right? We're all human, especially in academia, and we are worried about the well-being of the patient, and the monetary consideration comes secondary. But at the end of the day, if you look at the entire healthcare and how you power this engine, healthcare costs in this country, and I'm not an economist, but I can tell you this for sure because I've been to G7 meetings representing the US and you name it, is the #1 component in our GDP, bigger than defense. And this is totally unsustainable, right? So unless we bring digital health or digitization or some sort of revolution or modernization into the healthcare, we cannot sustain to provide the same healthcare. And at the end of the day, at the same time, if you look at the healthcare in this country, it's the best healthcare in the world. And if you want to stay at the top, right? And I used to live in Canada, and I have my friends who used to be jealous, but then they realized that I made the right move moving to US. But anyway, so what I want to tell you that we need to do something about the cost. Don't compromise the quality, but we need to take care of the cost of the healthcare. And the only way we can come with reducing the cost and optimizing the treatment arrangements is through the digitization. So the next revolution in healthcare will not come from the bench science. So if you're looking at the next 10 years or decade, it will come definitely from the digital component. Okay, from promise to practice, right? So what are we doing in response to all these challenges? So we have a number of challenges. We have the challenges that's technical, we have challenges that is practical, and then we have a challenge that is economics, right? Because at the end of the day, if there is nobody to pay for it, nothing we can do about it. So we created what we called AI test bed, which powers next generation of trusted AI. So it's ecosystem for characterizing the new AI and ML technologies, discover of new risks and opportunities, translating AI and ML technical capabilities to business opportunities, applied experiments to operational context to drive innovation, and deal with cyber attacks. Because you could today kill a patient without entering the hospital room, right? You can increase his IV with, I don't know, his glucose if the patient is diabetic, do all kinds of crazy things. So the hospital is a very dangerous place because you're kind of exposed to and open to all kinds of potential situations that are not necessarily controlled or not controlled at least to the best of our knowledge. So we build trusted and reliable AI models. So we build this infrastructure platform that enable us to evaluate and facilitate the continuous monitoring and training of AI ML models operating in real-world application. We process and deploy AI ML to improve with a set of tools and data exploration. We identify model errors and drifts, and then we have a bias assessment and mitigations. And then we are deploying there on this platform federated reinforcement learning. We are planning for about 40 plus modules. This platform is module driven. It's like a ladder system, which are all interoperable. So in a sense, depending on the type of problem we are trying to solve, deploying this platform, we'll be utilizing not necessarily all the components of the platform, but maybe some of them that will work in orchestra to solve our problems. I must share with you a very good news. One, we have signed about a month ago a 5-year research agreement with FDA, Food and Drug Administration, where my program and Frost Institute will be responsible for developing methodology for evaluating software as a device, where the software is driven by AI algorithms. We are the only university, to the best of my knowledge, in the country that got this honor to do that, because it's very sensitive, as you can imagine. Because this methodology actually will drive the entire industry. For those of you who are not very familiar with FDA drives about 25% of all the economy in this country, because it's Food and Drug Administration, and they have the authority to approve all the drugs, all the medical devices, and all the food quality in the country. Now, in addition to getting this agreement signed, we also are recipients of this money just arrived about 2 weeks ago of NSF and FDA award to study data drift in this type of environment, and it's a 2-year award that basically based on this agreement that enable us to understand how to create this methodology. And I call it, as I said already, analytics of analytics, but it goes beyond analytics of analytics. It's more in the realm of building multimodal AI solutions, because you're fusing different type of models and you're looking for specific applications. So in a sense, it's sort of in the realm of this cartoon. So you need a machine to test the machine, and then this will test you for some sort of a health problem, right? So that's exactly what is happening nowadays. Okay, so this is the architecture of our test bed. So we have healthcare, we have EHR, radiology, we have IoT devices, we have digital health and other applications. Remember what I told you at the beginning, that we are not just doing medical application, nor we are just doing weather applications. We are looking at horizontal technologies that powers many applications, academically grounded problem of national significance that have commercial value that may or may not be monetization. And then there we have number of modules, and number of modules are growing. And the nice thing, and here we have Professor Wu, who is part of my team, and Alex, who is our data scientist, that are integral part of development of all these different modules. And we are building them very, how to say, very organically and also hierarchically, so they all depend on each other, but at the same time can be used by itself or in a small kind of orchestrated algorithms. So the good news is we also have real-time data. When I arrived here, I was able to form a relationship with MedStar, which is one of the biggest providers of healthcare in Washington, Virginia, and Maryland area. They have about 10 million patients. So we have an access pretty much to any data sets, real data sets that we want. We also have relationship with Vanderbilt, Emory. I have a paid appointment in Veteran Administration, where I have IRB approval and access to the biggest electronic patient database in the world. It's 23 million patients, all veterans, about 5.2 billion records, and about 800,000 of them have genetic data, who they voluntarily donated. So we are doing experiments, and we are running this not on baby data sets, not on simulated data. We are actually have a real world data that we are using to actually validate our algorithms that we are developing. Okay. Now, when we are working with FDA and we are trying to help them out to understand how to evaluate software as a device, we found very interesting things, and I don't know how many of you are familiar with FDA. Probably not many because I wasn't before I started to work with them. It turns out that federal approval of devices to go to the market is totally different from the drugs going to the market. What it means? It means that devices go to the market much faster. So they have to go through the first and second level of approval, and then they're already on the market. And then what happens if for whatever reason they do not adhere to the specific behavior, then they do what is called field correction, right? Let's say you get, I don't know, hip implant, and something doesn't go well, then there is a report by the company who produces hip replacement. So basically we let the cat guard the milk, right? So the same company who produced the device is doing the reporting and report to FDA that this hip replacement had a problem. And there is another problem. And the problem is there because all this information flows through physician, which has, of course, propagation delay, right? Imagine that all the hip replacement failed. You need to have some sort of immediate broadcast mechanism to report to all the people who have this device, there is a problem. We don't have it in place, right? So these are the things that we are trying to address together with FDA and trying to see how we can preempt this problem. And if there is a problem, how we can real time address the issue in a very effective way so that it does not create a lot of problem and challenges to the patients. And we're not doing all of this in isolation. As I said, we have a pretty large group here at the University of Miami. But we're also working with the University of California, San Francisco. We're working with Vanderbilt. We're working with Emory. And we're working with other medical schools and organizations, University of Maryland, of course, and VA, that are not just providing the data and resources, but also providing the scientists and their experience in what they're working with. So this is the model evaluation system that we built, and this is something that we built for the NIH grant that I mentioned to you, AI for health disparities. So this platform is used there. We use it for diabetes, but nowadays it will be used for 20 other groups around the country to do all kinds of AI evaluations. And then there is a clinical use. We are able to address the data shifts and other problems. And this is again FDA inspired and project that is run in collaboration with FDA. We also done a lot of work, and this is work still that started actually at the University of Maryland while I was still there with tuberculosis. So we've done some work on actually very interesting story here, how we got the data set. We got it from people who illegally crossed the border. And it turns out that there is actually a world rule where, of course, US participates, and if people cross the border illegally, you have to make their x-ray. And the idea is you have to fight tuberculosis around the world. So if people have tuberculosis, you have to treat them. You don't deport them, right? You catch people who cross the border illegally. Eventually, you have to send them back. And the reason it's interesting that the University of Maryland got a contract from Department of Homeland Security to read the reports, nothing else, right? And they were reading it using radiologists, nothing automatic, nothing to do with AI. But what was interesting for us that we were able to get our hands on this report. And while people were interested in kind of a binary solution, does the person have tuberculosis or not, there were some incidental findings in terms of some nodules and other things that people have. And one of a sudden, we got over 2 million, I don't remember how many reports we had there, but 2 million, right? It was 2 million or 3 million, something like that. De-identified reports where we had nodules, we have some sort of problems, and then we use this data, of course, to do all kinds of analysis. And this was a tremendous kind of findings for us from the research perspective, so we can do all kinds of exciting things. So this is tuberculosis. Then we also work on privacy preserving production platforms to support federated learning. This is Dr. Wu, who is heading this in our group, and he's doing phenomenal work in trying to understand how to do what we call convergence of the technology. So he's converging the concept of federated learning with the blockchain solutions to actually propagate the information, to do what you call the short information sharing, but also to create trusted execution environments where, without getting an access to specific raw data from the medical perspective, to do all kind of analytics on top and come out with all kind of aggregations and interesting kind of findings. So this is our Yuval testbed, which is part of our AMA head grant, which was mentioned. I think it was a special project, but there is a name that I didn't call it. But anyway, it was called by name in the Python's report as one of the leading projects in the country by NIH, and we are part of this through National Alliance for Health Disparity, and we are looking at how to use AI to combat health disparity in this operation, in this environment. Challenges. So I given you tremendous amount of information, good number of exciting results. But what are the challenges? And the challenges are plentiful. There are many things that we still need to deal with, such as data heterogeneity, reliability of servers, and of course malicious clients. Believe it or not, one of the most expensive bridges in the world are the bridges for medical data. So it costs you more to recover from the breaches and exposure to the patient data than, let's say, if you have a breach with the banking or other financial institution data. And in conclusion, so we unveiled the importance and key challenges of trusted AI framework. And trusted AI is going to continue to be one of the main challenges and probably one of the leading topics that you'll find in funding agencies, but also in academia. Because as you hear from people who are AI savvy, not AI savvy, technically savvy or not, people don't trust, right? And they don't trust for multiple reasons, and some of the lack of trust is justifiable, and some of it is just pretty much normal kind of human situations where people don't trust, period, right? So what we need to craft a strategic roadmap that take us from promised lab to market, right? We have a lot of exciting things in the lab, and not everything or most of it make it to the market. Like, we've been fortunate here so far at the University of Miami, as I said, we've submitted 5 disclosures, 2 went to the patents, and the other maybe 2 on the way. One was kind of put as maybe as a trademark. So our focus here lies in constructing commercially viable platform for the establishment of the trusted healthcare AI framework. Okay, so this is my goal as the director of this program, and we are on the way. We are far from being there, but we are definitely on the way, and we are making a big success. And what we would like to do and inspire to do is to reach academic success with commercial viability, and we have positioned ourselves as leaders in the evolving landscape of contextual AI, and our leadership has been supported and basically proven by our recent substantial awards from FDA, NIH, and SEP, NASA, and now actually Google is about to establish a center and a lab with us around actually looking at the fidelity of medical devices. So that's a great thing for us, as well as we're working with a number of other industrial sponsors, and of course we continue to operate under the umbrella of our NSF's Carter Center. Our platform here is basically our kind of robust and reliable solution to AI problems. And I want to leave you here with this cartoon that is very profound to my test. And I think this is something we have to take very seriously. Because while we're relying on AI, it's not clear what we are doing about actually developing ourselves. Any questions? So Ludmil, I did exactly on the dot for 50 minutes as you requested, and I'm open to questions now. Yeah.
Great talk. Thank you so much.
Sure.
So as we look to more and more, I guess, commercial deployments of AI based in like healthcare situations, where do you see the standardization or standardized testing and stuff or regulations coming into effect? Do you see there being like standards developed that say if you develop an AI algorithm for FDA, you have to test or according to this process, or like how do you see that evolving as time goes on?
Well, here's my experience. In my career, while I've been full professor at the age of 32, for full disclosure, I managed to do many other things. So I was a director of the big center at NIST, and I wrote a lot of standards myself, PIPs and other standards. Standards, to make them real, they have to be industry driven. And most of the standards are actually developed under the umbrella or orchestration of the government, but by the industry. So if the industry doesn't buy into standards, the standards become dead, right? However, there is another angle in optics. 30% of all the business in this country come from the government. So in order for you to deal with the government, you have to be government compliant. That's why I think it's so important that IDIS has this relationship with FDA, and I'm signing a new agreement with NIST. Because NIST now was given an authority by the White House to do all the testing for the cybersecurity of the medical devices. Okay? So we as an academia become a Switzerland. We are a neutral ground. So what I'm doing for FDA, what my group is doing for FDA, I'm developing methodological assessment that doesn't do the testing, but guide FDA how to do it, right? So we have tremendous influence on the government is stopping short by saying we are the government, right? Which gives us another opportunity as researchers to go to all the commercial outfits and get their participation to learn from us how to get up to speed to become government compliant and what the state of the art. Also, once you assess methodologically what is there in novelty, it drives next generation of novelties because you understand what is missing, where the gaps are. And this is where us as academicians, this can drive us to the next quantum jump, if you will, in novelty. So it's not just helping the regulatory process, it's also moving the science to the next level. That's how I see it. But to answer your question directly, I think the best standards came from what I've seen from the committees where you have industry and government working together. If industry is not participating or not driving the standards, they will not be adopted, they'll not happen. That's what I think.
Questions?
Everybody's tired with milk. You should have been serving cappuccinos. Yes,
I have a question.
Sure.
So, a lot of these machine learning methods and neural networks, people compare it to a black box where, yes, it works on this problem, on this problem, but I don't even know that people really have a strong understanding of why it works, or at least maybe to a point, but beyond that, is that something that is a little bit unsettling? I mean, can we apply it to all of these problems if we don't even know why it works?
My answer is no. And what we're proposing here is not applying the existing solution to specific problem, is to create what I many times mention as analytics of analytics. What we want to triage and analyze the existing solution. And the next level, and this is my last technology disclosure here at UM, where we create a multimodal approach of solutions. So, but it's not a single solution to the problem. So you triage the problem and you try to understand how you can fuse different AI models to feed the description of the solution. So it's not having a cat in the bag and then say, let's take it. And neural networks is a passe, by the way. I mean, some people may not agree with me, but this is something that is really very much disappearing from the landfill of AI. The next generation of the AI is contextual AI, and it goes is a multimodal AI it's a next generation of kind of chat GPT, but at a much kind of a more sophisticated level. And this is where I mentioned during my talk that the concept of NLP is coming back because at a certain point people say it's a written book, people know how to do it. But now with the multi-modeling and the bigger size of the models, NLP has again emerged as another field of research where you can actually take advantage of this methodology to solve this multi-modeling approach. So to answer your question directly, is no. I think it's no longer, you have a problem, you have a solution, let's make it. No, I think it doesn't work anymore. And what do people understand AI fully? They don't. But you know what? The way AI evolved, in my opinion, and this is just my personal opinion, people are not supposed to understand AI fully because the moment they understand AI fully, it will be singularity. And we are far from singularity, right? So AI is a field of research which is evolving all the time based on learning and studies. And what we understand today drives the new innovation of tomorrow. So we are going through this multimodal or kind of cyclic improvement of solution space. And that's how I see it. And I may be wrong, I don't know, but that's my intuition, because if it would solve specific problems, then the whole field will kind of cease to exist, or we will have canned solutions and become commodity, which is not interesting for scientists. Sure.
Just like long ago, computers were constrained like to companies. Do you think that, and now everyone has more or less like a computer on its cell phone? Do you think that in the future, AI is gonna be at some point that we will be able to perform self-diagnostic?
So diagnostic for what?
Like for everything, or perhaps like.
Well, nowadays the patients are very much empowered, but what I believe in integrated AI with the human in the loop, right? It's not going to be autonomous where the devices will diagnose, and maybe in certain cases devices will diagnose. So you're talking about like device diagnostics, right?
Yeah.
I think in certain situations it will, but I think most likely we'll go into the area where you have integrated AI with the human in the loop. And the human here would most likely be a physician or specialist, not the patient. Although patient will be very powerful in terms of the knowledge, but the actual decision about diagnostics and the treatment regimens will come from the specialist.
And when do you think that perhaps need to start to training medicals or medical school to?
Yesterday, because I tell you my experience, I have tons of people every day, and it's very sad, coming here to me from Miller School of Medicine, and are saying, we want to be doctors of tomorrow, we don't want to be doctors of yesterday, we have zero education in technology and AI in our medical curriculum. And I talked to the dean of medical school, and they're kind of aware, but things are not moving, at least at the University of Miami, at the speed it should be. There are other places like Mayo clinics and things like that where this is happening. There is a new specialty, which is clinical informatician, where people actually sit for the boards. So there is some sort of movements in this direction, but we are far from that. I'm teaching courses in digital health because I believe it's a must. So that's something that I started when I arrived here, where I'm trying to bridge the gap, but I'm teaching them from computer science perspective. Perhaps something like that should be taught from medical school, where they should be looking at anatomy or any other kind of physiology, and invite people like myself or bring technology into the medical care. But this is something that needs to be revolved from the educational perspective. But the most modern physicians nowadays, and I'm working with many of them, they stay in line in front of my office, honestly. Here, and the same thing with the University of Maryland, those are the futuristics and understand. They said, we don't want Yelena to do, we're just scary. We don't want to do clinical care, we want to do what you do. And I said, you know what, you better go to your office and do what you do, because I'm getting older.
All right, last question.
I had a question about like new ventures that want to work with the initiatives that you're leading. Are
Sure.
there commercial opportunities? And then the follow-up question was about CRISPR genome editing. Are there applications in AI in that space as well?
Well, I'm very fascinated with gene editing. And, the big professor here, my better half, Yakov Yesha is here, and he can testify that for the last 10 years I'm on his case talking about gene editing, because I believe this is something amazing and actually inspired by high performance computing, or enabled actually by high performance computing. In terms of ventures, the answer is yes. So you're more than welcome to talk to me or anybody in my group, Wilson or Alex, and they'll tell you what we are doing. Not all of this is venture. Some of it is technology transfer. Some of it is actually going into the venture, depending on your interest, your background, and what you would like to achieve. You're more than welcome to at least to learn and see how you can fit in.
All right, let's thank